Chapter 1, Locating Places on the Earth. Open quote. The globe of the Earth stands in space, made up of water, earth, fire, and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic. Close quote. The big questions: 1. What is a map and how do we use it? What are its main components? 2. What are coordinates? How can latitude and longitude be used to mark any location on the Earth? 3. How are local time and standard time related to longitude? Imagine that you are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help, or you might look at a map of the city. In previous grades, you learned a little about maps, and in this chapter, we will study them in more detail. Let us play a game. Examine the map of this small city, Fig 1.1. Imagine that you just got off a train at the railway station and you want to visit the bank marked on the map. Which way would you go? Are there other possible ways? Can you locate the public garden, the school, and the museum? If you want to proceed from the bank to the market, which way will you go? This is where a map comes in handy. A map is like a treasure guide. It shows you where things are and how to get to them. Notice the 4 arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful.
Let's explore. On the map in Fig 1.1 given on page 8, 1. Mark the hospital. 2. What is the meaning of the blue-colored areas? 3. Which is farther away from the railway station, the school, the Nagar Panchayat, or the public garden? As a class activity, form groups of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it, and a few neighboring buildings. At the end, compare all the maps and discuss. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc. A bigger area, say your district or state, or a very large area like India or even the whole world. In a map, you look at the surface as if you are viewing it from the top. An atlas is a book or collection of maps. As you will discover, there are several kinds of maps. Physical maps, which mainly show some natural features such as mountains, oceans, and rivers. See an example in Fig 5.2 in this textbook. Political maps, which show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories, and their capitals. Thematic maps, with a specific kind of information. Examples include Fig 6.3 and Fig 8.1 in this textbook. In addition, there are 3 important components of maps: distance, direction, and symbols. You have already experienced the first 2 while navigating the map in Figure 1.1. Let us now define them more precisely. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. Let us go back to our map of a small city, Figure 1.1. Each centimeter on the map, as printed here, represents a certain distance on the ground. Let us suppose it is 500 meters. We say that the scale is 1 centimeter equals 500 meters. Now, turn to the map of India in Fig 5.2 in Chapter 5 of this textbook. The scale is represented in the bottom left corner by a ruler with 500 written above its length and kms on the side. It simply means that this ruler, which measures 2.5 centimeters in the printed map, corresponds to 500 kilometers on the ground. So, the actual distance between 2 points represented on the map depends on the scale that the map is using. Let's explore. Draw a simple map of a school's playground. Let us assume it is a rectangle, 40 meters in length and 30 meters in width. Draw it precisely with your ruler on a scale of 1 centimeter, 10 meters. Now measure the diagonal of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. Let us return to the 4 arrows at the top right of the small city's map. They point to 4 directions, which are north at the top and moving clockwise east, south, and west. These are called the cardinal directions, also known as cardinal points. Other than these, intermediate directions are also used: northeast, NE, southeast, SE, southwest, SW, northwest, NW. Most maps simply have an arrow marked with the letter N, which points to the north direction. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list below. 1. The market is north of the hospital. 2. The museum is southeast of the bank. 3. The railway station is northwest of the hospital. 4. The lake is northwest of the apartment blocks. Taking your school as the starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. Symbols are another important component of maps. Our map has small drawings of actual buildings and a few other elements, but there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings, for instance, a railway station, a school, a post office, for roads and railway lines, and for natural elements such as a river, a pond, or a forest. In that way, numerous details can be shown in the limited space available on a map. To make maps more easily understood by a variety of users, map makers use specific symbols. Different countries use different sets of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India, or parts of India. A small selection of them is shown in Fig 1.2 on page 12. Let's explore. Draw a rough map of your locality or your village, including your home, school, and a few other important landmarks. Show the cardinal directions and use a few of the symbols shown in Figure 1.2 on page 12 to mark some important features. Map symbols, Figure 1.2. Railway, broad gauge, meter gauge, railway station. Roads, metalled road, unmetalled road. Boundaries, international boundary, state boundary, district boundary. Water features, river, well, tank, canal, bridge. Religious places, temple, church, mosque, chhatri. Settlements, settlement, graveyard. Public services, post office, PO, post and telegraph office, PTO, police station, PS. Natural features, trees, grass. These are examples of standard map symbols used by the Survey of India on maps of India. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere, but is slightly flattened at the poles. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try to flatten them on a table. You will see that you cannot do it without tearing them at the edges. Now, consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the Mars, the stars, and constellations in the sky, etc. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metal, plastic, or cardboard. Here we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, a globe will better represent the geography of the Earth than a flat map. Let us now explore some of its features. A. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops, all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So you would give directions like, open quote, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance, close quote. This will allow your friend to precisely determine your location. Now consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces, from A to H, see the image, and numbers, from 1 to 8, in between the two sides. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from D2 to D4. Let's explore. Using the same terms, write down your move if you play black and respond with the same move. Answer. If black responds with the same move, the move is D7 to D5, written as D7 to D5. The system used in these two examples may be called a system of coordinates. Thanks to their 2 coordinates, the stationery shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. Hashtag B, latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and bottom are the 2 poles. Halfway between them is the equator. Note the circle marking it, see Fig 1.3. Imagine that you stand on the equator and travel towards one of the poles. your distance from the equator increases. Latitude measures this distance from the equator. At any point during this travel, you can draw an imaginary line that runs east and west, parallel to the equator. Such a line is called a parallel of latitude, and it draws a circle around the Earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move northward or southward, Fig 1.3. Latitudes are expressed in degrees. By convention, equator equals 0 degrees, 0 degree. North pole equals 90 degrees north, 90 degree N, South pole 90 degrees south, 90 degree S. There is a connection between latitude and climate. Around the equator, the climate is generally hot, torrid. As you travel away from the equator towards either pole, that is, as your latitude increases, the climate becomes more moderate, temperate. Closer to the North Pole or South Pole, the climate becomes cold, frigid. You will learn in science why this is so, and also why we experience different seasons in the course of a year.